Okay, so we've been talking about finding domain. And when you look at a picture of a graph, let's just say we have a graph here, and here's my picture of domain. And let's say it just stops right there at 3, and it's over here, and -5. Okay, so if I'm talking about my domain here, I'm talking about how far to the left and how far to the right does it go. And when we talk about that direction, left and right, we're talking about what are the x values. So it's saying, what are the x values that work here? What are the x values that are in the graph? And so I can say that it goes, x is greater than or equal to -5, because here it's starting at -5. It doesn't go anywhere to the left of that. If we look over here, it's not over here at all. It starts here and goes this way. And then over here at 3, it looks like it's going to kind of hug the asymptote there. And so then it's just going to be less than 3. We don't say it's equal to because it's not actually going to touch that line. And we don't say it's bigger than it because it doesn't go to the right. That's when we have a graph. The point of this video actually is not the graph. The point of this video is, what if you have an equation? Now, when you have an equation, you're talking about looking at x's and things like that. So what if I had y equals 2x plus 4. Let's just say that. So when we're looking at this, if we don't look at the graph at all, we're saying what x values are okay to plug in. And there's all kinds of them here. We could plug in 7, we could plug in 3, we could plug in -1, we could plug in any fraction or decimal that we want. We could even plug in pi if we wanted. We could go as negative as we wanted to. There's really no limit to what we can plug in there because any number can be multiplied times 2, and then we can add 4 to it. So it's really not a big deal to have this right here. In fact, when you're trying to find domain, there are only 2 rules that we really need to worry about, because there's 2 things that have restrictions to them. For example, if we have a fraction, we've talked several times about how we cannot divide by 0. This is a big no-no. So when we're looking at domain, we're saying, okay, most of the time everything works, but one of the things that doesn't work is if you have a fraction, you can't have 0 on the bottom. So we look for that so that we can say that it's not that. Let me show you an example of that. Let's say y equals 2 over 3 minus x. Okay, so again, the rule is, I have a fraction here, the rule is I can't have the bottom equal to 0. And so we're actually going to do the opposite of that. We're actually going to figure out when does it equal 0 so that we can say it's everything but that. So I'm going to set that equal to 0. And I'm solving an equation here. I'll just go ahead and solve. So we get rid of the 3. So now I have negative x equals -3, divide by -1, x equals a positive 3. Okay, so that means that your domain is all x but x equals 3. So that's just one way to write it. We could also write it that the domain is x does not equal 3. So that just is saying that it's all x except for x equals 3. There's a couple other ways, but I think these 2 are pretty much the 2 ways to go. So this is how you find the domain when you have a fraction. Now, not all fractions mean that you're going to have a domain of not something. Sometimes you have a fraction that really just has no problems whatsoever. Let me show you an example. What if I had y equals x over 2? And so remember, we have a fraction, so we have to worry about when does the bottom equal 0. And so I set up an equation, 2 equals 0. And see, here's the thing, there's no x here. So that means that that could never equal 0. 2 never equals 0. So then when we're saying our domain, we're saying, hey, there's no problems. You can plug in anything to the top. That's okay. It's just the bottom we have to worry about. So the domain then is going to be all reals like it normally would be. I said that there was 2 rules that we need to worry about. The other rule we need to worry about is square roots. Because if you remember, we can't square root a negative number. And so when we're looking at this, we really need to worry about negative numbers when we have a square root. Now, one thing that's kind of subtle and I want to point out to you is negative numbers are on the other side of 0, right? 0 is kind of like this fence between, how's that for a fence? Horrible, actually. Which way do fences go? They go more like this. Whatever. Okay, so 0 is a fence between the positive numbers and the negative numbers. So I'm actually going to once again use 0, but I'm not using 0 because at 0 it's a problem. I'm using 0 to figure out where is that fence, where is that boundary that I have to worry about so that all of a sudden I have negative numbers. So let me show you an example of that. So let's say I have y equals the square root of x minus 5. So I'm asking myself, when is the inside of this negative? Okay, well first I'm going to figure out when is it 0. Remember, I'm finding that fence. So I go ahead and solve it. And when x equals 5, the inside of that is going to be equal to 0. And by the way, it's okay to square root 0. So it's okay that we would have 5. I could plug in 5 here and that would be just fine. But it's not okay to have a negative number. So now I'm looking at what would make it negative. So we look at either side of 5. I look at below 5 and I look at above 5. And I'm trying to figure out which number would make it negative inside. So if I plugged in 6, for example, so if I have the square root and I plug in 6 for x, I would get 6 minus 5 is 1. Well, 1 is a positive number, so that's okay. So 6 is good. What if I plugged in 4? 4 minus 5, well, that's negative 1. That gives me a negative number. So 4 is a bad thing, which means I can't have numbers on this side of 5, and this side of 5 is smaller. So x cannot be smaller than 5, because then I would get negative numbers. So again, our domain is what can you have. So my domain has to be bigger than 5, right? Because it can't be smaller. 6 was good. 6 is bigger. So x has to be bigger than 5. It can also be equal to 5, because then I have the same thing as 5, and I would get 0, and then you can square with 0. That's okay. So this would be your domain for this one. The last thing I want to talk about is function notation. All this time I've been saying y equals 2 over 3 minus x, and I've been saying y equals the square root of x minus 5. Well, there's a better way of writing that, and that's saying, let's get rid of that y. There's too many variables. I'm going to write, instead of y, I'm going to write f of x. And instead of y, I'm going to write f of x. Or, you know what? Let's change that. Let's not write f of x. Let's write g of x, because it doesn't always have to be an f. It can be another letter so that we can tell it's a different function, not the same one. And so then, if you remember, on the f of x, we found that 3 made it 0. So I want to show you what you can do with that. So if I write here f of 3, you'll see that I replace the x with a 3. So now instead of x, I have a 3, which means now whenever I have an x, I need to put a 3. And so instead of an x, I'm going to put a 3. That's what that's telling me to do. So instead of having to say, put 3 in for x, is all I have to write is f of 3, and I know what's going on. And now I get 2 over 0, and we cannot divide by 0, so that means it's not part of our domain. Okay, over on the other one, instead of g of x, what did we find? We found that if it was less than 5, so I'll pick a number less than 5. Let's plug in 3 again, because that's less than 5. So that means I'm going to take 3 and I'm going to plug it in wherever I have an x. So I have 3 minus 5. And let's see, 3 minus 5 is negative 2, and we can't have that, right? We can't have a square root of a negative number. So that's not in my domain. So with function notation, that's how it tells you what to do, what to plug in.